So why do we care, right? From a business perspective for software, right? There's really three main views that businesses take. One is, why do I exist? Who are my customers? Why am I building this product? Someone's going to use it, right? The other two main concerns is my ability to actually build that value that someone wants to use or buy, right? That's usually our DevSecOps processes, our concepts, the way we do our engineering work, right? And then there's the product itself, right? How do I deliver, how do I operate the secure product that someone wants to use? But there's two main challenges to that. One is the process, right? It's constantly changing. The tools, the technology, 5 years ago, AI wasn't a thing. Now it's everything, right? That's impacting the way we're building things. That's the way we're using things. That's the way we're imagining the future. But they're not static. The second challenge, the reason most of us, I think, are here, is a security piece, right? Traditional software security was, I build this product, I build this moat around it, and I defend the moat, right? But then DevSecOps came along. Then came this integrated CI/CD pipeline, where what I've done is instead of having this moat that I have to defend, I have created this super highway of a bridge between the developer's world and the operational world. And now you have to defend that. So I've exponentially increased the attack surface of the system that I have to defend and I have to secure. And, some disheartening, facts, right? One is the application layer is where most of the vulnerabilities occur, right? The moat's irrelevant. They're just getting, I think Luke had the could have versus the should have, right? Almost everything they're getting at is because all those could haves that we're not being able to siphon off or defend against, right? 91% of organizations knowingly release vulnerable applications. They know their stuff isn't secure, but they're releasing it anyways because of the economics that are driving their businesses. 57% of vulnerabilities are left unresolved by developers. CISOs are just releasing and praying for the best. They're hoping you find someone else's vulnerability before you find theirs, right? Right? Or they're just not doing the patches, 60%, right? And the reality is, security must engineer to lifecycle applications. How do we do that, right? That's kind of what we're all here to talk about, right? And some of the things, we had some great deep dives. I'll skim through those as I go through these. But the first one is third-party software. We actually don't build software from scratch. We write glue code, right? We take this, and this. And part of that is this overall complexity of our systems, right? It's just too complex for any one team or one organization to build all of it, right? Some examples, right? So I think it was Kara mentioned Log4j, right? Thinking about adversaries, right? Microsoft has observed China, Iran, North Korea, and Turkey exploiting Log4j. It was prevalent throughout, because everyone uses Log4j for their logging. This free open source software, Microsoft uses it, Oracle uses it, like AWS uses it, everyone uses it, right? And it totally kind of, killed us as an industry, right? Approximately 63% of applications had first-party code flaws and 70% had flaws in third-party, right? So they're everywhere because we're all using open source software. I think Kara had some examples of looking at places of origin. A couple other techniques that one can use is thinking about how many maintainers. When you start looking at, what open source features should I use? What are some just really high-level things can I look at? One is, does it have an active maintainer community? Because if I only have one maintainer, who's peer reviewing it? Who's evaluating? Who's keeping that accountable, right? So I want to have a larger number than one. You figure out based on your risk tolerance. Number of days past the commit, is it being maintained? Is someone actually looking for when the CVE is found against an open source, they're actually going to fix it? Are they, a lot of open sources, they'll let you know when they're doing peer reviews, right? There's ways of doing that through the way their processes, the way their pipelines are set up. Don't just download the binary, right? Just because it's open source, someone's already put in a container for me, build it yourself, please, right? Because that way you can do a static and dynamic evaluation of that source code and you know what's in that binary, right? And also, if you have, military folks, whatever, government, if you have access to known, bad actors, are they using the same pseudonyms for these accounts that they're checking stuff in your open source, right? So these are the types of things you can start looking at from an open source risk mitigation perspective. The other one I'll talk about, this is the new topic, I think, for today, is quality, right? Software quality, right? It's been eating our lunch since the beginning of software. The initial bug was, an actual bug in the server, but, right, it still matters, right? Especially, software quality persists to reflecting the characters like reliability, usability, performance, and security, right? Why does it matter? Well, from a traditional perspective, right, when you manage a project, you have this cost, schedule, and scope construct, right? The thing that I always tell people is that I should never negotiate quality when I negotiate those three triads. Because if I do that, what happens is in terms of schedule, I'm going to be late. In terms of cost, I'm going to be too expensive. And in terms of scope, you're not going to get everything I promised. Because I have to deal with defects, right? In an agile world, right, modern way of thinking of things is, that's all a constraint. It's set in stone. When they draw the triangle, they say, okay, I have sprints, I have dedicated resources as a constraint. I have this quality thing that I can actually negotiate. Is it good enough? Right? That whole sprint demo at the end, right? But then I have this value. The problem with this is that I can quantitatively, economically, through surveys, whatever, I can balance constraint and value. But what happens is quality almost always gets ignored. It's the last variable, it's the least important variable from a business perspective, from a mentality. Now, it can come back to haunt you economically, right? Especially if you do get owned by somebody, right? But that's the dynamic. From a pure, U.S., economy, right? Operational failures are chopped to 1.81 trillion in the U.S. GDP, right? To which security failures is a good bit of that, right? So how do I do this? How do I think about this? Well, I have these weaknesses, these flaws, these bugs. Well, if I'm designing and I'm building code securely, right? There's things I can do in my coding, my architecture, my design, and my requirements, right? We've talked about some of them today. From a quality perspective, though, studies have shown that 1 to 5% of all defects are weaknesses or vulnerabilities, right? So for every defect you find, 1 to 5% of them might be exploitable, right? Into that could aspect of your process, right? And just to kind of put a number on that, right? Everyone's seen in the airlines the Dreamliner, right? The Boeing hats. Well, that airplane has over 14 million lines of code, right? And studies have shown that if you are an average quality, right, you have 600,000 defects per million lines of code. If you're above average, which I hope the Dreamliner is, because I fly a lot, right? They still have 420 vulnerabilities they have to deal with. They're probably made into the operational environment, right? If they're average, which I hope they're not, they have 4,200, right? The quality matters. And so how do you think about quality? Well, you think about it is defects injected versus defects removed, right? And so what are the techniques, what are the things I can do to inject less defects or to remove them faster, right? We've talked about some of them already in terms of design, in terms of removing static code analysis, that they're defect removal type of practices and processes. But so the thing is just traditional software, right? These are the phases where they're injected. These are the phases that they're traditionally removed. The same thing is true for vulnerabilities and weaknesses, right? And this is why we're so critically focusing on, design, security, and from the beginning, because that's where 70% of those defects are being injected, right? Because what's true for software quality is still true from just good cybersecurity, cyber engineering perspectives as well, right? These fundamentals have not changed, right? We're just thinking of it from a different lens of security, versus just the higher lens of good quality software. But the CI/CD pipeline matters too, right? We already talked about SolarWinds, so I won't re-hit that one, right? But another example is Git, right? Has anyone heard of Git? GitHub? Everyone who does open source uses GitHub, right? Well, back in 2022, they had a vulnerability that was exploited. In total, 332,000 websites were found as potentially vulnerable, including 2,500 residing in the .gov domain, right? Because everyone had that open source. They had that. They're using Git, right? So your CI/CD pipeline matters too, right? But attacking the infrastructure, the way to get into our operation, is not a new concept, right? So here's an example. Back in 2014, a decade ago, right? Someone basically attacked a German steel plant by getting a virus into their administrative system, which happened over the course of probably a decade or so, got integrated with their production system, right? And this is like molten lava, like steel plant, right? Major damage occurred by getting through their equivalent to a CI/CD pipeline. So the techniques have always been around. We're just now really starting to see them from a software development world into operational world as that cyber physical environments are really collapsing. So how do I address this holistically, right? So we think about it to software assurance, right? And what is software assurance? Software assurance is ensuring that the system only functions as intended and does nothing else, right? Basically, it does what it should do. It does not do what it could do because it's not what it should do. To go back to our keynote this morning, right? And I want to be able to prove that systematically, right? And how do I do that? How do I structure my argument to say, hey, this no kidding only does what it should do and nothing else? Well, there is a technique for that, right? Got to put up a little bit. It's building an assurance case. Insurance cases, if you're in the avionics world, right, safety of flight, right, it's a common technique used, right? They use to say that this system is safe. It's not going to crash. It's not going to, so the safety world, there's lots of standards around it. I can take that same engineering discipline and I can apply it to software development processes. Now, it's a little bit more abstract when you do this because I don't have the laws of physics unless I'm doing, the cyber physical perspective, right? But I can begin saying, here is my claim that my product only does what it should do and nothing else. And then I can systematically walk through and build a tree structure of arguments and provide evidence to support my arguments on why it's only doing what it should do. What are the constraints that I've put? What are the controls I've put in place? And then I also have other people, or even myself, can look at that and throw rocks at me. It's called defeaters, right? Where they say, I hear your claim. Here's my counterclaim. And if my counterclaim is true, your claim is false. In which case you now have to defend yourself against those as well. Until you can systematically build a structure where there's no more defeaters, right? So you can actually win an argument from it using an engineering discipline, right? And that's really where a lot of developers get in trouble is people throw rocks at them, say this system could do this, and this could go wrong. You can't get approval for this, right? Or I find like even standards like controls. Well, applying a control just to be complying with a control does not necessarily make your system more secure, right? Did I apply the control in the right way to mitigate the right risk? Or if I've already mitigated that risk in some other way, using some other control, this additional control is actually worthless. In fact, this additional control is more code I don't need that I now have to maintain, and it could potentially be exploited because I've increased my attack surface for no good reason, right? So how do I make those arguments with those authorities, right? I need to have an engineering discipline. I need to be able to show I have thought this through. I systematically evaluated this, right? So an assurance cases is a great way of being able to do that. It's an engineering technique that one can use. So engineering security, right? We're no longer building hardware into which we install a molecule of software, right? We're building software of which we happen to use hardware, right? Almost every system out there, even a pregnancy test, right, is software. Who knew? So what are those perspectives? What are the things I can do from a software assurance perspective? It goes all the way back to the system engineering V, right? I can begin thinking about what are the risks, version control, what are the metrics, right? There's all through this process, there's different techniques one can use, and I'm just going to skim over a few, right? And I'm going to focus on the software engineering lifecycle. The main one, the first one being requirements. I've seen lots of places where they go, my software security requirements is be compliant with NIST standard X or FAA standard X, right? Thank you for coming. I appreciate it. What's wrong with that, right? Well, part of it is the state-specific security solutions are not real requirements. Because they're not in the right terminology. They're too generic. They don't necessarily put in the right context of the system that I'm building, right? They're too narrowly focused on a particular application, right? Use SSL. Why am I using SSL? Because you want me to. Well, why, right? Justify that. Give me the requirement in which I will pick SSL. I might pick SSL as my implementation, as a design decision. But don't constrain the requirements prematurely. Compliance mandates, right? Use audit logs. Okay, fine. How does that make me more secure? What's the intent of that goal, that requirement? Focus on select controls. Asking designers are complete, so that's a little late. They want to know what my constraints are before I design, not after I design. Or don't actually elicit any requirements because I can't find anyone who knows enough about security to help me do this, right? Or I don't want to spend the time to educate them. I might find someone who really knows cybersecurity, but doesn't speak engineering speak. Well, we need to figure out how to bridge that gap too, because they have great knowledge, they have great experience. I need to get them to actual requirements that my developers can build and design to. And then, I also need to understand, understanding the need is not sufficient. I also had to think about anticipating misuse cases, right? Developers are not usually good at thinking about how people are going to abuse their system. Right, and so one of my first software development tasks I have, I built it was the E2C, so it's a aircraft control for the Navy, right? And I would get these bugs back, and it was like, why would they have pushed that button or that, right? Well, because they're a bunch of 18-year-olds straight out of military basic training, and they're bored, and they push the button, right? And so that's true even from the cybersecurity, they show that mentality, but because I can, right? And so I need to think about the misuse cases, right? What's that threat analysis? What's the attack methods, right? A lot of this, Alex gave a whole talk on, so I'm going to skim through it, but basically I need to do some threat modeling, right? And I have to have a defender's mindset. I have to, and really systematically walk through that, right? We've come a long way with, with attack and CAPEX, and we have some good resources that engineers can use as a checklist of really thinking like an adversary, even though they've never been an adversary, right? And then you can talk through how some people talk about stride already, so I'll skip that. But I can also work that into my agile lifecycle, right? We have these basic roles like Scrum Master, right? Well, we can have a persona non grata. Have a security person be there and be that persona non grata. Think of those misuse cases. Think of the ways you would not want to use that system, and feed that. Do really high-level, quick threat modeling of every user story. How can that user story be misused, right? Feed that into your development lifecycle to really get people, the developers, thinking about these things and understanding the importance of these things, right? And then I can use MBSE, again, before I had a couple of talks about model engineering, so I'll fly through this one as well. But you can actually have workshops where you bring people together and you systematically walk through different architectural views and you solicit the different feedbacks of threats. How do we mitigate this, right? Does our system already take care of that, right? And systematically work through that and build some models. But who you bring to those workshops does matter. You have to have the right representation of the right background knowledge, right? So you need, the people who are going to use the system, because you don't want to create a mitigation that your users are going to hate and they're going to avoid it. They're going to undermine that control, right? Anyone had, passwords that are so complicated you have to write it down? Like you just can't remember it. Between the different key combinations. Well, that is an example of someone putting in a security requirement that is systematically undermined by the user base because it's stupid, right? Right. So you need people who are going to use your system to be part of the system, right? But then you need some cyber experts. You need some people who have background in different type of attacks, different ways systems are abused or misused. They're keeping up with the never-ending announcements of various, attacks and things of that nature. That itself is a full-time job, right? And then you have the engineers and designers. They all need to come together. All DevSecOps and some users need to come together and really think through the threats of your system. And then you can build threat scenarios. Again, Alex already covered that one, so I'll keep going. And then I have to remove the defects, right? How do I check on some things, right? There's lots of different types of testing techniques out there, right? But the key here is you can't test software assurance into a system, right? A lot of people think, I just run these tests, I just integrate these tests, right? All testing can do is prove that you pass those tests, right? It can be used to prove the lack of quality. It can be used to prove the lack of software assurance, but it cannot be used to prove the presence of software assurance or the presence of quality or presence of security, right? It can only be used as the other way around. It can prove it's not there, but it can't prove it is there. So be careful. Don't over-trust testing tools, because the people who sell these things sometimes overpromise, right? But keep that in mind. That said, you should definitely use them because it's better than nothing. But don't overtrust the output. That's all you have to do when you have a secure system. It will fail you every time. So kind of a summary, right? I need to really think about software assurance. I need to think holistically. All these techniques need to be added up and put together so that I'm able to really build a trustworthy, predictable, and a timely system. And that's really at the heart of, I think, why we're all here, is that this is hard, and we're all trying to figure that out. So with that, I will send us to our break. We'll be back at, 3 o'clock. 3 o'clock. Thank you.